So, like I said, pedigree simply means a family tree that is used to study the inheritance pattern of a trait across generation. All right. So if you look at this now, for instance, this is a father. This is the first generation in this family. And then this man carries the trait we are talking about. May not be, is not disease at this point now, it's trait. Let's say the person carried the trait we are talking about now. What you notice is the woman did not carry the trait. In the offspring, a male in the offspring have the trait, a female in the offspring have the trait, and then two males does not have the trait. Now, then another family also got married. The woman have the trait, the woman doesn't have the trait. Now, by the time they gave birth to children, one female have the trait, the other female does not have the trait. Then one male here with the trait and a woman here with the trait got married and then gave birth to two children. These two children does not have the trait. I mean, this one have the trait, this one doesn't have the trait. And what we are talking about is widow's week. Widow's peak is this thing that is out on this lady. Widow's peak, you see, that is that here, widow's peak. If you pack your hair this way, you can tell if you have widow's peak or not. I don't have. All right. Now, widow's peak, that was the trait. Now, if you look at the trait now and study how the pattern of expression of inheritance or pattern of transmission, you can see that it's not all males that are affected. It's some males are affected, some males are not affected. So that tells you that this disorder is not forced. It has nothing to do with X or Y with sex chromosome. So it's not sex linked. It is, of course, just it is it has to do with all other chromosomes. We call it autosomal disorder. It has nothing to do with sex chromosome. Any disorder or any trait that has nothing to do with sex chromosome, we call it autosomal. So it's an autosomal trait because it does not have anything to do with sex chromosome. So that tells you that because there's nothing that tells the predominance in male or female, anybody have it at any point. So I could talk about that more in upcoming chapters. Let's go. So I just want you to see how we can trace inheritance pattern through our pedigree. Let me see. Okay. So pedigree can be used to make predictions about future offspring. We can look at that and say, okay, this parent will likely not have this will not likely happen in this offspring, all of that. The same way when we say that AS and AS should not marry, AS should marry AA, because with pedigree you can calculate, you can do the projection and say, okay, the likely children will be this, the likely children will be this. It may not always be accurate because all of them is probability, of course, but it can do predictions. We can use the multiplication and addition rule to predict the probability of a specific phenotype in a future generation. All right, recessively inherited disorder. Many genetic disorders are inherited in a recessive manner. I'll talk about that. They range from relatively mild to life-threatening disorder. Now, behavior of recessive allele. All right. Now, this is what I started to explain the other time. Please, you need to be with me carefully at this point now to explain this to you. Now, recessively inherited disorder show up only in individuals homozygous for a trait. I will explain it. Carriers are heterozygous individuals who carry the recessive allele but are phenotypically normal. They don't have symptoms, but they carry it. So inside, they have the disorder, or they have the gene, but in terms of expression, they don't express any disorder. They are not sick, but they actually have the gene for the sickness inside of them. I will explain it. Most individuals with recessive disorder are born to carrier parents. Albinism is a recessive condition characterized by lack of pigmentation in skin. Now, let me show you this now. So this is a parent. These parents have normal phenotype. These parents have normal phenotype. Phenotype simply means physical expression. So when you look at their physical expression, they look normal. But the fact that they look normal, does that mean they are normal in terms of genotype? No. This guy, genotypically, this guy, we call it a carrier. When we are looking at the genotype, we call it carrier. But of course, phenotypically is normal. This guy as well, we call it carrier. And that is the same case where AS belongs to. AS is a carrier for sickle cell. AA, we say, is a normal individual. And SS, we say that they are affected. So we say AS is a carrier. We say AA is unaffected. And then we say sickle's SS is affected. Affected means that we can see the symptoms. We can see the symptoms. Don't mind me the way I'm writing, but you go as I wrote there. So AS, a carrier, is carrying but no symptoms. AA, unaffected. SS, affected. So the same thing here. Heterozygous are actually carriers. So when you come here now, you see this is AA, says normal, not affected. AA, carrier. Uppercase, heterozygous, carrier. And here, the person we have expressed the disorder. So the A, the lowercase a, is actually the disorder. So when we say something is recessive, so remember now, when you say something is dominant, it means the other time when we say this is dominant trait, we said the person that have this genotype is going to be purple. Say this person will be purple. So at what point will somebody be white? We say this will be purple. We also say this is also going to be purple. So who is going to be white? White is the person that have lowercase p, lowercase p. So the fact that p, uppercase p is dominant, it means this is recessive. Lowercase p is recessive. So white is recessive. For white, before anyone can be white, it has to have two lowercase p's. And that means for any recessive trait, for a recessive gene to be expressed, you must have two of it. That's what you saw here too. Albinism is a recessive trait. It's not a dominant trait. For somebody to be albino, the person must have one gene from father and one gene from mother. If the person just have one gene from father and no albino gene or albinism gene from mother, the person cannot express it. So for someone to be albino, that means both parents carries the gene. They may carry it like this, like both of these parents now are carriers. They are not expressing anything. They are not albino. They look like nothing. But inside of them, they have the recessive gene. They have the gene. They are called carriers. Two carriers, when they get married, they can give rise to albino. The same thing if you look at this. I will do this here because of space there. So if you look at this now, if somebody have somebody get married and marry AS, and you cross it. Now, what this means is that these guys are going to, it's going to separate. So it's separate, and we have this. This will also separate here. So this will separate, and we have this here. By the time you couple it together, you are going to have AA, you have AS, you have AS, and you have SS. So in essence, you're going to have probability of 1/4 that is going to be this, 2/4 that is going to be this, and 1/4 that is going to be this. What that means is this: the child that is going to come, these parents are both carriers. They are both carriers. They are carrying the disorder, but they have no traits. They have no symptoms, rather. So this child the first child have tendency to be this, but it's just 1/4%. 25%, 50% of the chance is that their children will be AS. And 25% of the chance the child can be AA or it can be SS. So that is what carrier and affected individual looks like. So if a recessive allele that causes a disease is rare, it's unlikely that two carriers will meet and mate. All right. Consanguineous mating, that is between close relatives, increase the chance that both parents of a child can carry the same rare allele, right? Because if two members of the family are giving birth to a child now, then there's going to be a likely chance that they may carry the same thing, and then because they carry the same thing, they may now give birth to a child that will express that trait. Those are the likely chances. So most society and culture have laws or taboos against marriage between close relatives, which in the real sense, if you look at it, aside from other factors that could be there, one of the major reasons, one of the disadvantages of having marriages within family members is that there are a lot of disorder that we could be carrying, but we don't know because it's not affecting us. So, but there's of course high chances that if siblings are going to likely be carrying the same disorder from their parents. So if the siblings now marry each other, then they will likely produce offspring that are now going to be affected by the disorder. AS, of course, is not affected by sickle cell, but SS is affected by sickle cell. All right, let's go. So the same thing with cystic fibrosis is also a recessive disorder, and it will need 2 copies of the gene before it can be expressed. All right, sickle cell anemia is also the same thing, which is what I just did. It's also a recessive disorder. An organism have to have 2 of it before it can be expressed. Okay, so this is a sample of sickle cell talking about it, that sickle cell carrier will be normal. The person will have no disorder, but the person that is homozygous, having the 2 traits, we have expression, and that is when you see the shape of this red blood cell affected, and then there will be oxygen deprivation, right? All right. Now, dominant inherited disorder. Some disorder are caused by dominant alleles, meaning that once you have 1 copy of it, for recessive allele, you need 2 copies. For dominant, you just need 1. Dominant allele that cause liver disease are rare and arise by mutation. Achondroplasia is a form of dwarfism caused by a rare dominant allele. All right, that is a dominant allele leading to that. And you see, once a copy is present, there will be expression. So as long as a copy is present, there will be expression. You don't need the two, uppercase D, to become to express the phenotype. You only need one. All right. That's a case of Occitan disease as well. Okay, so multifactorial disorder now. Some disorders are not just affected by gene alone. They can be affected by other life aspects. So many diseases such as heart disease, cancer, alcoholism, and mental illness have both genetic and environmental factors. All right. No matter what type of genotype, our lifestyle has tremendous effects on phenotype. So sometimes now you are in the States and you notice that in that state, because of the weather in that area, you have a lot of allergic reaction during summer. But you realize that when you travel to New York, or you travel to cold environments that have different climate, you notice that what you feel during summer is different from the way you feel it in Texas. So that tells you the environment have a factor in this expression of this gene. Of course, when we say there's allergic reaction, it's of course due to the presence of a gene that is there causing the allergic reaction. But um, environmental factors have a way of amplifying it. All right. Genetic testing and counseling provide information to prospective parents concerned about family history. It tells about chances of what they have or what they can transmit to their offspring, and then that also inform who they can marry or who they cannot marry. So this is what deals with telling someone that have AS now not to marry someone that have AS, because potentially there could be a problem. Right? So that is what genetic testing and counseling does. All right. I'll skip this. We've looked at this when we look at probability. That's that. Okay. I don't need this for this chapter. All right. So I'll stop here on this chapter. We've looked at this. It's just review again for that. All right. So I'm going to stop here.